Hello my dear students, I am Dr. Anamika ahirwar going to take lecture on the KDP process model. In this lecture, I will cover the third model of KDP process model. The other two models I had already discussed in the previous videos. So let's start from the third model, that is hybrid model. The development of academic and industrial models has led to the development of hybrid models, that is, models that combine aspects of both. One such model is a 6-step KDP model, which is shown in figure, and this model is developed by Kiosk et al. It was developed based on the CRISP model by adopting it to academic research. The main difference in extensions include providing more general, research-oriented descriptions of the steps, introducing a data mining steps instead of the model step, introducing several new explicit feedback mechanisms. The CRISP DM model has only 3 major feedback sources, while the hybrid model has more detailed feedback mechanisms. Modification of the last step, since in the hybrid model, the knowledge discovered for a particular domain may be applied in other domains. Now we can see the figure. This is a 6-step KDP process model. Now the first step is understanding of the problem domain. This is a very important step. This initial step involves working closely with domain experts of knowledge, the problem, and determine the project goals, identifying key people, and learning about current solutions to the problem. It also involves learning domain-specific terminology, a description of the problem, including its restrictions, is prepared. Finally, project goals are translated into data mining goals, and the initial selection of data mining tools to be used later in the process is performed. The second is understanding of the data. This step includes collecting sample data and deciding which data, including format and size, will be needed. Background knowledge can be used to guide these efforts. Data are checked for completeness, redundancy, missing values, possibility of attribute values, etc. Finally, this step includes verification of the usefulness of the data with respect to the data mining goals. The third step is preparation of the data. This step concerns deciding which data will be used as input for data mining methods in the subsequent step. It involves sampling, running correlation and significance tests, and data cleaning, which include checking the completeness of the data records, removing of collecting for noise and missing values, etc. The cleaned data may be further proposed by feature selection and extraction of algorithms to reduce dimensionality, by derivation of new attributes, say by discretization and by summarization of data, data granularization. The end results are data that meet the specific input requirements for the data mining tools selected in step 1. That is understanding of the problem domain. The fourth step is data mining. Here the data mining uses various data mining methods to derive knowledge from pre-processed data. Evaluation of the discovered knowledge is the fifth step. Evaluation includes understanding the results, checking whether the discovered knowledge is novel or interesting, interpretation of the results by domain experts, and checking the impact of the discovered knowledge. Only approved models are retained and the entire process is revisited to identify which alternative actions could have been taken to improve the results. A list of errors made in the process is prepared. The last step is use of the discovered knowledge. The final step consists of planning where and how to use the discovered knowledge. The application area in the current domain may be extended to other domains. A plan to monitor the implementation of the discovered knowledge is created and the entire project documented. Finally, the recovered knowledge is organized. So, this model emphasizes the iterative aspects of the process, drawing from the experience of users of previous models. It identifies and describes several explicit feedback loops. First is from understanding of the data to understanding of the problem domain. This loop is based on the needs for additional domain knowledge to better understand the data. Second is from preparation of the data to understanding of the data. This loop is caused by the needs for artificial or more specific information about the data in order to guide the choice of specific data pre-processing algorithms. Third is from data mining to understanding of the problem domain. The reason of this loop could be unsatisfactory results generated by the selected data mining methods requiring modification of the project's goals. From data mining to understanding of the data, in this step, the most common reason for this loop is poor understanding of the data, which results in incorrect selection of data mining methods and a subsequent failures. Example, data were misorganized or as continuous and discretized in the understanding of the data step. Fifth is from data mining to the preparation of the data. This loop is caused by the need to improve data preparation, which often results from the specific requirements of the data mining method used. Since these requirements may not have been known during the preparation of the data step. Sixth is from evaluation of the discovered knowledge of the understanding of the problem domain. The most common cause for this loop is invalidity of the discovered knowledge. Several possible reasons include incorrect understanding or interpretation of the domain and incorrect design or understanding of problem restrictions, requirements, or goals. In these cases, the entire knowledge discovery process must be repeated. The seventh is from evaluation of the discovered knowledge of data mining. This loop is executed when the discovered knowledge is not novel, interesting, or useful. The least expensive solution is to choose a different data mining tools and repeat the data mining step. Awareness of the above common mistakes may help the user to avoid them by deploying some countermeasures. The major applications of the hybrid model has been used in medicine and software development areas. Example applications include development of computerized diagnostic systems for cardiac SPECT images and a grid data mining framework called Grid Miner Core. It has also been applied to analysis of data concerning intensive care, cystic fibrosis, and image-based classification of cells. Now, this covers our hybrid models of the KDP process model. It is one of the KDP process model. So, in the next lecture, we will see the data mining areas where these areas are applicable. Basically, data mining is applicable in medical area. Researchers are very much use this area for their research. So thank you once again. So we will meet in the next video. Till then, take care.